Alright, we're going to try this one more time. It's really late o'clock and I need to go to bed. But you guys are probably working on your do now right now and wondering how you're supposed to do those questions. Well, I'm going to show you some examples. Let's say we were doing alpha decay. And we could do it for, no, we'll do it for uranium-235. So, if I was doing it for uranium-235, I know the mass is 235. I'm given that in the problem. However, I still need to figure out what the atomic number is. So for that, I would look on the periodic table, and it's 92. Now, because I said it's alpha decay, that means an alpha particle is emitted. So we know that one of the products is going to be an alpha particle. Now you just have to figure out what the numbers are for the mass and for the charge, or the mass and the atomic number. You want them to balance out on reactant side and product side. So you need a 231 on top, because 231 plus 4 is going to give you 235. And then you need a 90 down here, because 90 plus 2 will give you the 92 that you have on the reactant side. Now, if you want to identify what the new element is going to be, because this is a transmutation, you have to look on the periodic table, and you'll see that the element with the atomic number of 90 is thallium. So that would be alpha decay. But I'm feeling dangerous. I could blow this up now. I showed you alpha decay. Boom. It's a new toy, guys. Bear with me, I'm playing around. Let's do beta decay. Oops. Let's do beta decay. Still annoying to write on this. I'll go back and put a C in there. Ah, look at that. Hold your applause, please. Hold your applause. Oh, thank you. Oh, thank you. So, let's say I have potassium 42. If you look on table N, you would notice that potassium 42, its decay mode would be a beta particle. That's what a beta particle looks like. If you forget that, the particles are on table O. I'm missing something though. I do need that bottom number, and it is 19. I figured that out by looking on the periodic table. And now I have to figure out what these numbers are. Now the top one's easy, because there's no change in mass with alpha particles. With the beta particles. They don't have mass. So when you lose a beta particle, the mass stays the same. However, you're losing a negative charge. So the charge actually goes up. 20 minus 1 is going to give you 19. So now you got to look up what element has a atomic number of 20, and that would be calcium. Now if you look at the mass, you'll notice that it's probably not close to 42, but that's okay. These are isotopes. The ones that you see, or the mass numbers rather, that you see on the periodic table are averages. Some of them can be much higher, some of them can be much lower, even if they're rare. So it's all based on the relative abundance. And we'll talk more about that when we review atomic theory. But this is how you would do the problems in the do now. Just look at the type of decay and balance out the numbers and identify what they are in the periodic table.